Hello guys and welcome to episode 8 where we talk about guards and authentication. To better understand the role of guards, let's take this example. Let's say you have an API that returns posts and the route is /posts with the method get. And let's say there's a client trying to make a request. Of course, to fetch your own posts on a social media platform, you have to be logged in. Not everyone should be able to call that route, so it shouldn't be public. Instead, we have to set in place a guard that makes sure that the request is actually valid. So it might check that the user is actually logged in, has a valid JWT token, or that the user has the required permission to access a certain route. So this is where the logic of validating a request and permissions should be. And this is what they say in the documentation. Guards have a single responsibility. They determine whether a given request will be handled by the route handler or not, depending on certain conditions like permissions, roles, and so on. Now, validating permissions or roles is known as authorization, but of course you also know authentication. Let's sort the confusion between the two. Authentication refers to who you are, your identity. So whenever a user logs in into a system and the credentials are correct, the system now knows who that user is. The user is considered to be authenticated. And most of the time, the server is going to provide an access token, a JWT token, to that user that they can use on every single request that they make. That way the server, checking the token and verifying it, can actually make sure that this user is who they claim to be. This process is known to be authentication. It refers to the identity, or it's the process of verifying someone's identity. On the other hand, authorization means or refers to what you can actually do on that system. So different authenticated users can have different permissions or roles. Authorizing a user means that you are verifying that this user who is already authenticated has enough permissions or possess a role that is required to access a certain resource on that server or perform a certain action. Authentication and authorization play hand in hand. They are both handled by the guards. Now you can have one single guard that does both, authenticates the user first and then makes sure that the user is authorized to access a certain route, or you can also have two different separate guards, one which is the authentication guard, which just validates the user, the identity of the user, and then if everything is fine, it's then going to call, or the request is going to go to the second guard, which is the authorization guard, which is going to make sure that this authenticated user actually possess the required permissions that are required by a certain route before accessing it. If everything is fine, then the user is going to have access to that route or to that resource and perform a certain action. If not, then it's going to throw an error. And we're going to see how this is done, so make sure to watch the video until the end. Now, if you've used Express before, then you know you used to use middlewares to authenticate and authorize requests, but middlewares are dumb by nature. They don't know which handler is going to be executed after calling the next function. On the other hand, guards have access to the execution context instance, meaning they know what's going to be executed next, which handler is going to be executed next. So it's a good idea to actually use guards and not middlewares in Nest, since it has that extra advantage. So let's say we had this route handler and we had some metadata saying that the roles should be admin if you want to access this create cat route handler. If you're using a guard, like we said, you have the context and you know which route handler is going to be executed next. And you also have access to the metadata of this route handler, which is very important if you want to check the permissions or the roles. So this is one more point, or this is to show you why you should use guards. So this is just to show you why you should use guards instead of middlewares whenever you're working on authentication and authorization. It's also important to know that guards are executed after all middlewares. We've talked about middlewares and how to create them in episode 5, but before any interceptor and pipe. And we've seen what pipes are in the last episode and how to use them to validate requests, validate data or the shape of a request. Now that we understand the role of guards, let's see how we can actually implement our first guard. First of all, I went ahead and created a folder called guards, and then I created a file authentication.guard.ts. Let's take a look. The first thing that you can see is that a guard is basically a class, just like pipes and so on. And it also has the @injectable decorator, the one we've seen when we created our own pipe and we've seen when we created our services, meaning they can be injected and can be handled by the IOC container of NestJs. We can also see that it implements can activate, which is an interface, And this interface provides a method that we should implement, which is called canActivate, which has access to the context, like we've said. This is the advantage of using guards, and which returns a boolean, true, false, or a promise if we have async, or an observable, like in RxJS. So of course, what we need to do next is to actually implement that method. Let's go ahead and remove this line and just keep return true, and let's add a log inside the guard. Okay, and now let's go to our customer controller and let's bind it to a single route handler. We can bind it on top of a controller, just like we did with the pipe, or on top of a route handler, of course, just like pipes again. But now let's try and do it on the get or customer route handler. Just like we have @use pipes, you can also have @use guards, which is also from NestJs/common. And it can also get an array of guards, as you can see. Now let's go ahead and call our authentication guard. So now it's bound to this route handler. Of course, we could have said new here, but we're gonna leave the injection to the IOC container. Okay, now let's go ahead and call this route. Let's open Postman and then hit on send. And as you can see, we got inside the guard, and then here we got the array coming from the route handler, because here we are returning this empty array. And this is because we have return true. We got access to the route handler. If we had return false and we saved, now if we hit on send, as you can see, we actually got an error. Status code 403, forbidden resource, and forbidden. Now the shape of the error might be different for you if you haven't been following or keeping up with the series, but basically I have an HTTP exception filter here, which is custom, where we shaped our own errors. But either way, you're going to get forbidden resource. And this is the default behavior by NestJs. If you throw false in a guard, it's going to throw forbidden. Now, usually, whenever you have authorization, this is a good error to show, but if you have authentication only, and you're trying to authenticate a user, it's better to show, instead of forbidden 403, unauthorized 401, for example. And to do that, instead of returning false, you can, for example, say throw new unauthorized exception. And then now if we save and open Postman and hit send, as you can see, we got unauthorized 401. Now this doesn't matter if you don't really care about the error thrown, but as you can see, if you have false, it's going to throw an error. If we have true, it's going to enter the route handler. Now if we try to call the create API, so the second one, post, hit send, as you can see, it was created. And then if we take a look here, in the route handler logic with body, which is this one here, and it did not actually print inside the guard. And that's again because the guard was only set on that specific route handler. Now if you go ahead and instead remove it from here and add it on the controller level, now if we hit on save and try to add another one, if we hit send again, as you can see, first of all, we got inside the guard. So we actually entered the guard, done our validation, validated the user, made sure that everything is alright. And then if that's the case, we're going to go to the route handler and then process that request. Now I added the code that was present, const request, which is retrieving the request from the context. Now again, if we take a look at execution context, we can see that it's an interface that extends argument host, which we've seen in a previous video, which I'm going to talk about again. We can see that we have a get class, and then we have a get handler function, which returns the handler method, or a reference to the handler method, that will be invoked next in the request pipeline, which was the advantage we talked about. Now, if you go back to argument host, and we see here, we can get the arguments, return the array of arguments being passed to the handler. We have switched to RPC, to HTTP, or to WS here, which is in the context of WebSockets. Here is the context of HTTP, which is our case. And we've seen the use of this in our HTTP exception filter before, where we had an argument which was called host, which is of type argument host, which was used to actually get the context, but we need to switch to HTTP since this is dynamic, and we could have had switch to WebSockets, for example. And then from this, we used to get the request, and then we would have the arguments of that request. Now here it's very similar, but instead we have execution context, which inherits from argument host, so it has the same method and methods and arguments, but on top of that it also has get handler, the reference of the handler, and then get class, which is the reference to a controller. So now it makes sense here, looking at this, context was switched to http.getRequest, we're actually getting the request. We can also say console.log, for example, let's say request.headers to print the headers. Let's open Postman and hit on get send. And as you can see here in the logs, we can see that we actually got the headers of that request that we sent. Accept, cache control, host, localhost 3000, connection. So now, usually whenever we have authentication or authorization, we care about the authorization part of the headers. So let's come here and then add some authorization. Let's say bearer token, for example, and add anything. And then it's going to be added to the headers, of course. If you take a look here, authorization. And now if we hit on send, if you take a look here, we can see that we have authentication, bearer, and then here we should have a token, which we should validate before returning true or false. So now you can see that the guard is actually starting to make sense. Now, usually whenever we log in, if the credentials are correct, we receive a token. But I'm not gonna go ahead and create an authentication module now and add all of that functionality. So instead, we're gonna be using this website, JWT.io, to actually simulate or to actually create our own token and then validate it and see how or what happens in our guard, since this video actually talks about guards. First of all, you should have a secret key. Of course, this should not be in a configuration file, and of course not in this file as well. So not in a config file, nor here. It should be in an environment variable file, so in .env, because this shouldn't be committed to Git. Be careful, this is very important. You should never commit any secret to Git. But for the purpose of this video, I'm just gonna keep it here, just to be quick. Usually you would have that in an environment variable, and then in the config file you do process.env, and then you read that property. And you never commit it, you add it to git ignore. The env file should be in git ignore. Anyway, now that you know that, to create a token with this secret, we can go to jwt.io, and then here I'm gonna place this token. And here, let's say, name John. Okay, so now this token has some information. The payload, which is the name of the user that logged in, which is John. And of course, we signed it with our own secret. Now, if you take this and then in Postman, add it here and hit on send. If you go back to our code, as you can see, now in authorization, we actually have a token that is actually a JWT token. So of course, we can use a library to decode that token and to verify that it's valid. To do that, you can go to the documentation and authentication and security authentication. You can see that they actually have a JWT module that they can register, and you can actually get it from NestJs/JWT, so we can install that package, and then we can specify the secret here, the option of signing a token. So whenever you're actually creating a token, you can set the global configuration here, when it's going to expire, and of course other properties, and you can do it whenever you're signing the token and not actually place those information here. Either way, let's go ahead and see how we can implement that. So inside of our customer module, inside of imports, I'm going to add this module. Of course, now we cannot actually have it here, we cannot import it because we need to install that package. So let's go ahead and do that. So npm install at nestjs/jwt. Now that it's installed, we can actually import that package and then that module, and then of course here in the secret I'm gonna add the secret, but again this should be in an environment variable file, and then using a config file you can read it, and then in the config file you have process.env, so you need to keep this as a secret. And then we set this as global true, so anytime we use the JWT module anywhere in our application, in any auth guard, in any module, anywhere, it's going to use this secret and then those sign-in options. If you have different secrets, you don't have to set this as a global. You can have different modules with different secrets, or set the secret whenever you're actually signing a new token, if you need to change the secret. But for now, let's keep it simple. To use that JWT module, we need to have a constructor here. Then we need to inject, so private JWT service of type JWT service. I had to do the import manually, but now if we take a look at this.jwt service we can see that we can decode a token, we can sign it, and here whenever we sign it, if you take a look at the properties, we can add our own payload. Now we're doing it manually here. Our payload is named John Doe, but of course we should do it in a code, so whenever the credentials are correct, you can create and sign a new token. And then you can also pass another argument, which is an options argument. So here, let's say the payload is something. And then the options, if you take a look, we have so many things here. Header, issuer, we have the secret. This is what I meant earlier when I said you can set the secret whenever you're signing a new token. So if we don't set a secret here, for example, it's going to sign using this secret here, the one registered here globally. But if we set it manually, we can actually override that secret. But now we don't really care about .sign, we care about verify. And verify, what it does is it actually decodes and makes sure that it's correct. Because decoding a token only gets us the payload and some extra information. It doesn't verify that this token is actually valid. It doesn't make sure that this token actually was created by our server using this secret. So, of course, we would need to use verify. I made our authentication guard a bit more useful. Now we are actually getting the request like we've seen, and then we're getting the token from the request by accessing headers and then authorization, and then splitting on the space and taking the first index, so not index 0, index 1, which is here, headers, request.headers.authorization, and then we are splitting this, which is bearer space and then the token, just so that we can take the token part. After that, we're checking if we don't have a token, then we are going to throw unauthorized exception. If not, we're going to have a try catch, in which we're actually going to try and verify using JWT service this token. So we need to verify it. Again, we're not specifying the secret here or any other options, because we're assuming that all the options are set here globally. But if we didn't have the secret here, of course, we would need to set it here in this function. So here we would have secret. Now, whenever we verify the token, let's see what happens. First of all, let's see what happens if we don't have a token here. So I'm gonna no auth, add no auth, and then hit on send. If you take a look here, cannot read property of undefined, reading split, and that's because we're actually trying, or we don't even have an authorization head. One way to fix that is we could actually take this part and also add it in the try catch block. And then now if we save and then open Postman and hit on send, you can see we got unauthorized. Now let's add our authorization again. So we have our token, and let's try to hit on send. As you can see, we got a response from the server, and we actually got access to the route handler this time. And that's because the token is valid. Now, if you recall, we are using this old secret here. Let's say we change that secret and we try to take this. We have the same payload, and now we add the new token here. If we hit on send, as you can see, we also got unauthorized. If you take a look at the error here, it says, and here in the catch, of course, we're logging it ourselves, it says invalid signature. And that means that the signature used to sign the token, which is here, this one here, is different than the one used to actually verify the token, which is here. They should be the same to make sure that this token comes from this server and it is correct. So you can see that now our guard is actually doing its job. It's checking that we have a token, it's checking that it's verified and correct, and then if that's the case, it's actually going to add the payload to request.user. So now if we go ahead and take a look at console.log request.user, let's save, and then here of course we need to go back to the previous token, which was correct, hit on send. If we take a look here, as you can see, we got the payload, name John Doe. And you're used to actually doing rec.user or rec.whatever in Express whenever in our middleware we verify the user. This is the same thing here. And now if you want to actually have access to rec.user inside of the controller for any reason, you can say at rec, and then here you can say, let's say, and then you can also specify that you want the user part. And then here you can say user, for example. And of course this need to be from imported from NestJs common. Also what I meant to say here was not this, but instead I meant to say this. So we're just extracting the user. Let's add the log user. If you hit on send, as you can see, we actually got the user from the request, because now we're just extracting the user part, which is here set rec.user, which is this, the payload of the token. So now instead of our controller, we can have access to the payload to the user part of the request. Now the part that we skipped, which is, if you remember, I said you are simulating the creation of a token here on this website, jwt.io. This part here, the sign in functionality in your application, where you have the user actually log in, send their username and password, and then you verify if your database contains those information. If that's the case, you create your payload, and then using the JWT service that we're using now to verify the token, you'd also use it in the first place to actually sign or create a token. We already talked about the sign functionality, and then you add the payload. Of course, here we didn't specify the secret again, because already we did that in here. We set the secret. So far, we've seen the role of a guard and where it's in our request response flow. We understood the difference and the relationship between authentication and authorization. We've seen how we can create a guard ourselves at injectable. It's a class, it implements can activate, it can return either boolean, promise boolean, or observable. And we've talked about the execution context and its advantage over using a middleware for validation of a user. And we've seen how we can also register the JWT module so that we can actually use the JWT service as well and inject it, so that we can verify a token and so that we can also sign a token like they have done here. And we've also seen how we can bind a guard on a controller level, so it will be applied to every single route handler in that controller, or how we can also bind it on one route handler, on a specific route handler, instead of the whole controller. There's also one more thing we haven't talked about, but it's simple. Just like global filters, we can also have app.use global guards, and then here we can say new authentication guard or any guard we want. And of course, we would need to pass an instance of JWT service in case we have a constructor and we are passing it here. I want to show you one more thing in this video, which is using Authorization Guard with this Authentication Guard, and then having our own custom decorator, which is the role, where we specify which role can access which controller or which route handler. So I went ahead and created another file, which is another guard called Authorization Guard this time, which also have, of course, the same characteristics of a guard at injectable, implements can activate, and then have the can activate here. But this time I'm just logging that we are inside the authorization guard, and then I'm just returning false. So now we have an authentication guard that checks the token and verifies it, and then attaches the payload to a user, and then we have an authorization guard that just returns false. If you remember, I said previously that we can actually pass an array of guards to @use guard. So here we can say authentication guard and then authorization guard. If you hit save now and open Postman and try to call an API, we got forbidden resource. If we take a look at the logs, we actually got the token and the actual payload, which are the logs here, console.log request.user and request.user, which are before return true. And then after returning true, of course, here use guards is going to continue, or the request is going to jump to the second guard in our array, which is in this case authorization guard. If you go there, we can see we got this log, which is inside authorization guard, so we know that we are inside of this, but we are returning false. If this was true, for example, if we hit on save, if we take a look here and hit send, this time we got an empty array, so we got inside of our route handler. Now the role of this guard here is going to be checking the roles of the user and comparing it to the roles of a certain route. So here we're going to set some metadata specifying the role that is needed for accessing this route. And then here we're going to check the user, rec.user, the role of that user, and if it matches, then we're going to say return true, else we're going to throw an error. Now it's good to know that this is a simple example. In real life scenarios, you might have more complex scenarios where you might have a database or a collection called permissions, or a table in your database for permissions, where you have a list of permissions attached to a role, and then you might have a user with a role ID that specifies the role that this user have, and then you might have all kind of relationships in your database. So here in your authorization guard, you might actually implement or depend on a module called Authentication Module, in which maybe you pass in the rec.user.id of that user, and then in your database or in your module here in the service, Authentication Module service, you might have a function that takes the rec.user.id and then goes to your database, fetches the list of roles and permissions, and then compares those permissions to the permissions or the metadata here that are required for this route. But to make it simple, in this video we're just going to add the role here in the payload. So whenever we are signing or creating a token for a certain user after authenticating that user and finding that the credentials are correct, we're going to add the payload. So we're going to add the name of the user who logged in and then the role. Let's take this, and then this is our new token now. If you hit on send, if you take a look at the logs, we can see that our payload now contains a role that we can use to compare the role of that user or that token with some role that we add here. We're going to see how to do that. In the documentation, we can see here that we can create our own decorators. For example, here they specified public as a decorator. They set the name here, and then they use set metadata from NestJs common, and then they specified here is public, which has a value of true, and then you will be able to use it here. So whenever you have add public in or on top of a route handler, you know that this is a public API, for example. I went ahead and did the same thing, but for my own decorator, which is roles. So now we created a roles decorator that takes an array of strings that specify the different roles. We could have admin in our system, maybe assistant, and so on. And then we use set metadata from NestJs common. We specify that we are setting roles to the list of roles, the array of string that we pass here. So now to be able to use that decorator, we could go to our controller, and then if you have the auth guard on the controller level, we could set it here at roles, and then it takes an array of strings, so we could have admin. This would mean that this controller can only be accessible by admins. And of course, we're going in our authorization guard to get this metadata, the required role, and then compare it to the rec.user role, so the role that the user has. Also, of course, this works as well on route handler level, so we could have it here, meaning these are only applied to this handler here and not to the other one, for example. But let's add it back here. Now, to get access to the metadata of the route handler or the controller, meaning the class, we need to use something called reflector, which is from NestJs core. So we're doing dependency injection here, and then if we take a look here, we can see if we say this.reflector dot, we can have get to retrieve metadata for a specified key for a specified target, and the target here means, for example, a class or a handler. We could also say get all and override. Let's see the difference. First, let's say get, and then here we need to specify the key, which is roles key that we specified here, which is roles. And then next we need to specify the target. We need to use context dot, and here we saw this before. We need get class, since our decorator or our metadata here, our metadata at roles is on the controller level, so get class. And now we can say or const required roles equal this. So those are the required controller roles. Let's make sure that it's working, so console.log. Let's see if we actually get admin. Let's hit on send. Let's take a look here, and indeed it said the required roles are, and then we got admin. If instead of get class we said get handler, if you save and hit send on postman, now we got undefined, and that's because the handler, meaning the route handler, doesn't have anything. Like this is not on a route handler, it's on a controller. Now if instead we had this on a route handler, get or customer, if we save and now hit on send, if you take a look, we actually got the required roles are admin. And now if we had class instead of handler, and now it's not on top of a class, it's still on top of a route handler. If we hit on send, again we got the required roles are undefined. Now in your code, sometimes you might have the guards and the decorators set on the controller level, and sometimes they might be set on the route handler level. So it's a good way, or it's a good practice to make it dynamic. Meaning instead of using get, we could use get all and override. This says that it retrieves metadata for a specified key for a specified set of targets and returns a first not undefined value. So here, now instead of specifying one target, we have an array of targets. We can say context.getClass and context.getHandler. Now if we save, and of course this should be like that, if we save and hit send, we got the required roles are admin. That's working for the controller level. And now if we set it on a route handler level, if we save and then hit send, we also got the required roles are admin. So now using the reflector, we were able to actually get the required roles or the metadata of a class, or meaning a controller or a handler. Now to get the user role, we can say const user role equal request dot user dot role, which now if you remember here we are setting the request dot user, and then here we already set the role as admin. Now for the sake of simplicity, instead of having roles, I'm gonna just call this as role, then role here, and we're gonna pass in one specific role, so it's no longer an array of strings, it's now one string only. So of course here it needs to be, let's pick this role, and then instead of an array of roles, we're gonna have one role, which is admin. So let's go ahead and log the user role as well. If we hit on send on Postman, we can see the required roles are admin, which is now a required role, and then we have the user role, which is also admin. I removed all the unnecessary logs, and now what we can do is simply say if required role not equal to user role, then we can return false. If not, we're gonna return true. If we hit on save and now open Postman and hit on send, we got the array. That's perfect, and that's because both are admin. But then let's say instead of being an admin, this user was actually an assistant. So now if we take this new token and then set it here, this is an assistant token. If we hit on send, we got an error, forbidden resource, and that's because the required role is different than the user role. Again, in real life scenarios, you might have a list of permissions instead of actual roles, but the idea is the same. You have a reflector, you have some metadata, you fetch the metadata from the controller or from the route handlers, you have your own decorator, you specify what values those decorators can take, and so on. It could be simple, it could be more complex, but the idea is the same. If you have any questions, please make sure to leave them down in the comments. If you're still watching, please leave a like, subscribe, share this video, show your support. Thank you so much, and I'll see you in the next episode.